Okay, folks, we are looking at page 32 in our red book, and we are trying to figure out what equation we're going to use from a question. So the little blurb is, do I have pressure, volume, and temperature for one gas? So I have a pressure here and I have a temperature here, but my volume is my question mark. So the answer to this question is a no. And is there a second gas present? In this instance, there is a no. So I can't use my combined. I have to use my PV is equal to nRT. So again, in terms of our setup, we are setting it up. I don't know why this won't right now. Down here, down the side, and we're reading our question. So I have 89,000 pascals. This is in my correct units of pascals, so I can use this. My volume is the watt part. That's my question mark. My N, I don't have a moles directly in the question, so we'll come back to it. My R is the fixed universal gas constant, so it's going to be 8.3, and my temperature is 20 degrees Celsius, but I can't use it in degrees Celsius. I have to add 273 to it to turn it into 293 Kelvin. So I've used this, this is the only thing I have left to do. So, seeing as I already know what my question mark is, I must be using the 24 grams of oxygen here. And this is going to go into my mass triangle where I put my mass on top and I put my molar mass of oxygen. So oxygen is O2, so that'll be 16 by 2. Remember, I need to use the mass number, which is 32. And when I do this piece of maths, I get 0.75 moles. Okay, so I'm now ready to go. We have always said the recommendation is you write out your formula because it may be worth 3 marks to you, and then we do the rearrange. So I want to have the V by itself. So to get the V by itself, this P has to come under the line. So I am now going to have N or T over P. And then I fill in all my pieces of information to match their symbol, like so, and divided by 89,000 to 89,000. I put this into my calculator as it just looks. I don't do little bits and pieces of it, like the top line first and then the bottom line. What I'm trying to do is minimize mistakes in using numbers. And when I am done, I am going to go to 3 significant figures, because we said 3 significant figures is the default. Maybe how I'm reading it may be 0.205 for you. We're not going to argue about it. And this unit is in meters cubed. So we've said earlier that volume has to be in meters cubed. Okay, we try another question. So obviously these are all going to be ideal gas equation questions. But if I look at this, how many moles of carbon dioxide are present in 720 centimeters cubed of the gas at 10 degrees and a pressure of 1 by 10 to the 5 pascals? So in this one, we are asked the question, is there pressure, volume, and temperature for a particular gas? There is. So I have volume, I have a temperature, I have a pressure. Is there details for a second gas? There is not. So I am now using my PV is equal to nRT. So again, we take our pressure. Our pressure was 1 by 10 to the 5 pascals. You need to know that it has to be in pascals. This unit is right. My volume here is 720 centimeters cubed. So this is not, I can't use this number as it is. Otherwise, my final answer will be out. So all you need to do to turn it into meters cubed is you multiply it by 10 to the minus 6. You just literally tag that on and you are now done. I can use this. It's asking me up here, how many moles? So this is my question mark now. My R is my 8.3. As we said, it'll be on the front of all your papers. And my temperature here is 10 degrees Celsius, which I can't use. I have to add 273 to it to convert it into Kelvin. We write our formula out because it may be worth some marks. And now I'm rearranging for N. So I would like to have N when I am done by itself. I'll leave it on this side just so we can see. So to do that, my R has to come under the line and my T has to come under the line. Okay, so N is going to be equal to PV over RT. And as we say, we just fill it in as it looks. So 1 by 10 to the 5 for P by 720 by 10 to the minus 6 all over 8.3 multiplied by 283. And when I'm done and I need to put it to one significant figure, it should be 0.03 moles, final answer. Okay, we then go over the page. So again, we read through carbon dioxide, pressure, liquid form in a fire extinguisher. 2 kilograms of carbon dioxide are released into the air as a gas on the discharge of the fire extinguisher. What volume, so this is my question mark, does the gas occupy at a pressure and a temperature? So straight away, do I have PVT for one gas? No. Is there another gas here that has something missing? Yes. So that tells me I'm using my PV is equal to nRT. So we read our question to find out our stuff. Here is my pressure, 1.01 by 10 to the 5 pascals. My volume, we've worked out, is my question mark. N, in this case, we'll drive straight into it. There's no moles mentioned, but there is 2 kilograms of carbon dioxide gas. So I can't use 2 kilograms. I'm going to put this into my mass triangle. I have to convert it into grams. I need to work out CO2 is going to be C has a mass number of 12. Oxygen is 16 by 2. So that is 32. 42 is going to be 44. So I'm now dividing 2,000 grams by the molar mass of carbon dioxide, which is 44. And when I do that piece of maths, I am going to get, let's change the colour of my pen so we can see the number, 45.5. My R is my universal gas constant, that is fixed, and my temperature here was 290 degrees Kelvin. I can use this because it's in the right units. So now I write out my formula. PV is equal to nRT, like so. I am now solving for volume. So to do that, my P has to come over my equals and it's going to go under my line. So V is going to be equal to nRT over P. And I'm now plugging in everything. So 45.5 by 8.3 by 290. That is going to be divided by my pressure of 1.01 by 10 to the 5. And when I am done, I'm going to go 1.09. And again, the units are meters cubed for volume when I use the ideal gas equation. Last question, and this one has a little kick in it. So again, this is our mandatory practical. So we will do our practical next lesson for you guys in 2023. It may be different for other class groups when they finally watch this. But this is going to be, as I say, our PV is equal to nRT. So reminds me, somebody has my barometer because it did not come back. So I need to remember to get that. So we read our question. We have a gas from a laboratory gas jet at 25 degrees in a 0.25 litre flask under the pressure of 73,327.3 pascals. Our sample of gas weighed 0.118 grams at a temperature of 25 degrees Celsius. From this data, calculate the molecular mass of the gas. So what do we know? We know this is our pressure, 73327.3 pascals. We know my unit is correct. I can use it. I have a volume of 0.25 litres. So we have said this has to be converted to meters cubed. So to do this, all we do is we put by 10 to the minus 3 next to it, and I'm now, my things are correct. Now, moles, we do have 0.118 grams of a gas, but we do not have any information on the gas. So in this instance, this becomes my extra info. So 0.118 grams is going to be extra info over here, and this potentially is going to be my question mark, but we'll go through to see. 8.3, my universal gas constant stays the same, and I have a temperature of 25 degrees. Can't use it as degrees, I have to add it to 273 Kelvin, and I end up with 298 Kelvin, and now this is ready to use as well. So I have a piece of extra info, but I have no info on the gas, so I can't calculate moles. Because I have 4 of the 5 things in my formula here, this has got to be my question mark, and I'm going to end up doing something with moles in a second. So we write our formula, PV is equal to nRT, Again, I want N by itself, so I'm going to put R under the line, I'm going to put T under the line, and I end up with N is equal to PV over RT, and now I plug everything in. So 73327.3 by 0.25 by 10 to the minus 3 all over 8.3 by 298. Plug that into my calculator, and when I do that, I get 7.41 by 10 to the minus 3 moles. So what am I left with now? I am left with moles, and I am left with the mass. So I am hoping that there is a mass triangle screaming at you. So 0.118 grams is going to go up here. My 7.41 by 10 to the minus 3 is going to go to my left-hand side. And when I do this, I am going to get 15.9 grams per mole, which is my molecular mass. Final answer. So for our mandatory practical ones, we have 2 steps that we need to do. We need to PV is equal to nRT, and in our second step, we need to use our mass triangle. Okay, and as I say, we will do the practical application of this, and we see where we go.